Happy morning, pre-algebra. This is the second to last, sorry, almost the last Monday of the school year. And so don't worry, we only have one more Monday to get through, and then we're done, and it's summertime. Hooray. Okay, I want you to get out your calculators and make sure you're on page 595 in your textbook. We are probably going, this is our last section to learn about, so we're either going to test Wednesday or Thursday. It depends on if we need kind of 2 days to get through this section and then to have a day of review, or if today you guys got it, nailed it down, we'll review the chapter tomorrow and then we'll test on Wednesday. So it just depends on the pace. So that doesn't mean go slow. Again, I'm going to be watching out to make sure you're working. But again, just a pace where you guys can be successful in learning. So page 595, here is today's joke. What does a vegan zombie eat? So a vegan, maybe you probably heard the term vegetarian. Vegetarians and vegans are a little bit different. A vegan will not eat any, I believe they will not eat any animal products. So a vegetarian doesn't eat meat, but they will eat something like cheese and milk and eggs, I think. I don't know about eggs. But a vegan won't eat those things. They won't have milk. They won't have anything that's produced by an animal, I think. But anyways, so what does a vegan zombie eat? Grains. Not brains, but grains. All right, 2 minutes in, and we got to start going. So today is our last section is talking about two special triangles that we can solve the sides. What are the lengths of the sides? Differently than the Pythagorean theorem. So as you recall, the Pythagorean theorem, a squared plus b squared equals c squared, and that works for any triangle with a 90-degree angle. And both of our triangles that we're looking at today do have 90-degree angles, but we're going to look at some exceptions that can make figuring out the sides a little bit easier. So our first triangle that we're going to look at is the 45, 45, 90. And this is, the degrees are, both of our degrees are 45 degrees and then 90 degrees. So because of that, the length of our sides are both legs, remember a leg, equal each other. So they're both going to equal A. So they could both equal 2, they could both equal 3, they both equal 4.279. But the idea is that they both equal the same. And then the hypotenuse, remember that's this guy right here, that equals A times the square root of 2. So A times the square root of 2. Now, the occasion that we'll see this in our example here is we're given the triangle and we need to find the side, typically the hypotenuse, but sometimes it's a different side. So here's our triangle, another one there. And looking at just example number 1, it says triangle ABC and triangle DEF are 45, 45, 90-degree angles. Find the length of the hypotenuse in DEF. So we have DEF, the length of our sides, our legs, are 3 inches, and we need to find X. So we know, here's what we know. We have 3 inches, we know 3 inches, and X. And I know that this side, so I'm going to, since we're solving for X, to find the length of the hypotenuse with our 45, 45, 90, we're going to have to do the length of a side. So remember, it's X would equal A times the square root of 2. So I know what A equals. I know that A equals 3 and times the square root of 2. So simply, what we can accept for the answer is that X equals 3 times the square root of 2. And that's how we would exactly write it. Now, if you wanted to find the exact number, it's going to be pretty weird. You would do the square root of 2 times 3, and it's going to be 4.242640687, on and on and on. So because it's such a long, non-repeating decimal, we just simply write it as 3 times the square root of 2. I think it's pretty simple. So remember, our side, the length of the hypotenuse, is the length of the leg times the square root of 2. So let's look at another example on that same page, looking at example number 1, guided practice at the very bottom. Look at that, just a perfect triangle. Wrong one. There we go. All right, in a 45, 45, 90 degree triangle, a leg is 11 meters long. What is the exact length of the hypotenuse? So we have 11 meters and 11 meters, because we know that these are both 45 degrees. We're already given that. They've told us that information. So we know, I'm trying to find x again. So we know that, again, to find the length of x, it's a times the square root of 2. So we know that x would just be 11 times the square root of 2. All right, pretty easy. We're always just multiplying the length of the leg times the square root of 2. So if you turn the page, you'll be introduced to that formula. And it says that the length of the leg equals the leg times the square root of 2. All right, so with a 45, 45, 90, the length of the hypotenuse is the length of the leg times the square root of 2, using this formula. All right, and for example, what if they gave you the hypotenuse and you had to find the leg? So if they said the hypotenuse were equal to 7 times the square root of 2, and you had to find the length of the legs, well, we could determine, remember, that this number, 7, is always the length of the leg, so using that information, 7 would equal x. Okay? So you may see a problem like that. Again, use the information that you know to find the answer. Alrighty. Let's move on to the next one. Now, our second and our last special rule with triangles is the 30, 60, 90. And so I'm not able to draw a perfect triangle. I don't have that shape automatically written in. But here it is. And this one's a little bit more confusing or challenging. There's a lot more going on. So let's call this A let's think of it like our height. This would be our height. It would be A, and that's just A all by itself. Hypotenuse is 2 times A whenever we have a 30, 60, 90. And then the base, so that's the bottom, it would be A times the square root of 3. Okay? So, looking at example number 2, here's what it says. The scale factor from ABC to DEF is 4 to 1, or 4. Use the scale factor to find the missing measures. So, we're not going to use the scale factor, we're just going to use what we know, using the information. So, I'm going to redraw the triangle. Oof, that's pretty pitiful. Let's draw a straight line, Devin. Alright, a little bit better. Go across, not so straight, but alright. So let's just say that this equals 30 degrees, this one equals 60, and this one equals 90, just for the sake of this problem. Alright, and they're telling us that this side equals 4 centimeters. Alright? So using our knowledge of what our formula of what our triangle should look like, let's start with the hypotenuse. That's pretty easy. So this one equals 2a. All right, so that would be if 4 centimeters equals a, then that means that this side is going to be 2 times 4, which equals 8. 8 centimeters. Are you following? Because we're using this formula, again, we can only use this with our special triangles. It's going to equal 8 centimeters. And then lastly, this bottom is a times the square root of 3. And so we would just write 8. Excuse me, not 8. It would be 4 times the square root of 3. Okay? And that would be centimeters. And you know what? We can actually check this by doing a squared plus b squared equals c squared. So let's actually prove that. Let's double check to make sure that this formula this really works. So let's choose a leg. So we have 4 times the square root of 3 squared plus 4 squared, and it should equal 8 squared. Alright, so I'm going to do, let's see, I'm going to do 3 squared, or no, excuse me, the square root of 3 times 4, square that, and that equals 48. Wow, that's odd, that's such an even number. So when I solved that, what I did the square root of 3, I multiplied it by 4, and then I took that and squared it, and I get 48. 48 plus 4 squared, that's going to equal, 4 times 4 is 16, and 8 squared equals 64. And would you look at that? 64 equals 64. Alright, so just proof that the formula that we're using, our 30, 60, 90 triangle formula, is accurate. We can use it. Alright, so one last example. And let's use the real world example on page 597. So it says a 10-foot ramp for loading an all-terrain vehicle onto a truck makes a 30-degree angle with the ground. Perfect. So like I need to move the Honda over here. So we're building a ramp to drive the Honda up the ramp. And so it says the ramp is 10 feet. Let's find the length of the base. So it says find y, the distance from the truck to the end of the ramp. Round to the nearest tenth. So if we know that this is a 10-foot long piece of wood that we're using, we're trying to find y. And if you remember, with our handy little triangle, I'll write it over here. This would be a, this is 2a, and this is a times the square root of 3. So first, let's kind of break down this side. That's what's going to make sense for me. So this is equal to 2a, and if I want to find a, I'm going to divide by 2 both sides, right? So that a would equal 5 feet. I wanted to draw an F. Alright, 5 feet. So we're talking about 5 feet high, but they really want us to find this problem. Y? What is the distance from the end of the ramp to the truck? Distance from the end of the ramp to the truck. So that's going to be a times the square root of 3. So remember, you didn't really need to do this step. I just did it to kind of show it. But so now we know that a equals 5 feet, so that would be 5 times the square root of 3, and that would be feet. And we're just going to keep it like that. No need to write the long decimal. Because actually, if we were to simplify, or excuse me, round the decimal, it does say it to round the decimal, doesn't though. We got to make sure we answer it correctly. So on our problem here, it does say round to the nearest tenth. So when I actually do the square root of 3 times